Hello, everyone, and welcome to another episode of the IoT for All podcast. My name is Ryan Chacon, and on today's episode, we're going to be talking about the current state of 5G and IoT, all the kind of good stuff related to 5G. And with me today will be Doug Kirkpatrick, the CEO and co-founder of Airiden. They're a rapidly growing startup building 5G radios to enable abundant wireless connectivity everywhere in the world. So the perfect guest to kind of talk about network coverage when it comes to 5G. I would truly appreciate it if you give this video a thumbs up, subscribe to our channel, and hit that bell icon so you get the latest episodes as soon as they are out. But before we get into it, we have a quick word from our sponsor. The We Talk IoT Business Podcast is back. Explore best practices, IoT use cases, and formulas for success on your preferred stream provider, or visit avnet-silica.com/podcast. That's the We Talk IoT Internet of Things Business Podcast. If you want to check it out on the website, it's www.avnet-silica.com/podcast. Welcome, Doug, to the IoT for All podcast. Thanks for being here this week.
It's a pleasure to be with you.
Yeah, it's great to have you. Let's kick this off by having you give a quick introduction about yourself and the company to our audience, if you wouldn't mind.
So I'm a PhD physicist by training. I've been in a variety of roles throughout my career, from being a research scientist to being a head of a next generation lighting company to being then a program manager and chief scientist at DARPA, which is the central R&D organization for the DoD. Then I came out here as a venture capitalist, and I found that I'd much rather be in the saddle driving the change, and got the opportunity to found and lead Airiden, and that's where my heart has been for the last 10 years. Airiden was initially founded by three of us. I describe myself as the technology Reese's peanut butter cup guy, and my two other co-founders were the chocolate and the peanut butter. So what we do that's unique is to pull two technologies together with something called direct polar modulation and gallium nitride, which is an advanced electronic material. And Earl McCune, one of my co-founders who unfortunately passed away, wrote books and books and books on direct polar, had been the evangelist for direct polar for about 30 years. Dubravko Babic did his thesis on gallium nitride back in the 80s at UC Santa Barbara. And it was us getting together after one of my forays as a VC, looking at another company, just having that classic Silicon Valley conversation over a beer on a bar napkin, saying, so Earl, you're doing this. And so Dubravko, you're doing this. And put the two of those together, independent of what we were just talking about, that means we could do this, right? They kind of look at me and go, yeah, but who would care? That's the art of these discussions, and that's the beauty and fun of doing this kind of thing.
It's always interesting when I talk to people who have a investment kind of VC background and just realize they're more suited for kind of being creators and wanting to really build something. And that's not everybody's like that, but it's always great to talk to people who've kind of played on both sides and realize that, hey, I want to be involved in building, and the investment part could be fun, but just in your heart, there's some satisfaction of being able to create something from scratch and bring it to the world. So it's pretty cool. So today we have some really interesting topics I wanted to run through. The first one, just at a high level, I'd love it if you could just talk about the current state of kind of 5G network, how 5G is impacting IoT, things like that, and just kind of set the kind of high level stage for our audience on that front.
So 5G today, as you experience it, is going to be dominantly experienced in large metropolitan areas. I sometimes refer to it on a global stage as 5G for the 5%. So you're in a situation today where in the biggest economies, China, the United States, Western Europe, and in the most concentrated spaces, San Francisco, New York, Chicago, where the markets are big, the mobile network operators have rolled out 5G in sometimes limited ways and sometimes full ways, but it's a creeping situation. 5G has some really powerful characteristics which haven't gotten out to the really experimental side of the world, where you're gonna start to see a huge amount of those changes. So if you think about things like IoT for agriculture or IoT for lumbering in remote places or mining in remote places, that's not really even feasible yet because the 5G networks and the emphasis of the big guys on the 5G technology platforms are focused on where all their current customers are, which is kind of one of those catch 22s because they talk about wanting to grow new business with 5G, but all the 5G installations are being installed where their old business already is. That's a that's a conundrum and a box that the legacy technologies that form the radio access network have driven them to. We at Eridan are driving a completely different paradigm. Our technology will be seen in those small agricultural communities and remote areas before we go into the big markets, because that's where our technology makes the biggest difference is in those small remote places. That's something that we're going to see a huge change in.
And, are there, as you talk about kind of the expansion of coverage, do you feel like they have plans to expand? Like, kind of how are they, besides, I mean, you kind of laid out how they're approaching it as far as they have existing customers, there's incentives for them to be focused on these big metropolitan areas and not necessarily going in directly into rural areas, which, like you said, will limit 5G's ability to enable certain use cases in IoT. Are there barriers to that continual expansion into those areas that maybe people out there listening may not really know about? Because I'm sure there's a lot of people who listen are like, yeah, we don't have 5G where we are. We're not able to utilize it for these use cases or even on a personal consumer level. Like, what are some of those barriers that are potentially in place right now that are probably holding that up?
They're mostly financial. And the challenge is that legacy technologies, we did this set of numbers a while back, maybe 2, 3 years ago, as we were starting to do our Series B raise. And somebody else had a very similar question. And Amy Lambley, our VP of Marketing and Business Development, and I kind of looked at each other and said, that's a damn good question. Let's go analyze that. Um, and so what we did is we sat down and said, okay, let's actually pretend for a moment that these coverage maps that they want to give you are true, which we know they're not. They're aspirational. Um, and you look at it and say, what would it actually cost for them to do this in terms of a CapEx? If they want to roll out 5G across the United States using legacy technologies, and we want to cover all of our roads, let's just say for the moment, we want to cover every paved road in the country. Well, today, about 6% of the lane miles in the United States have 5G. 6%. I live in San Francisco. My relatives live in Reno. I can drive the 250 miles from San Francisco to Reno, and that's on a major highway, I-80. And for 52 miles, I have no 5G. For 28 miles, I have no G. You can imagine if I'm driving the 2-lane highways through the backways of Iowa and Mississippi, that it's not as good as I-80 between Reno and San Francisco. So it gets a lot worse. So that 6% number starts to loom. If I want to cover everything, that means I need 16 times more base stations. Each 5G base station is 3 times more power consumptive than its 4G little brother. So you're talking about a 48-fold increase in power consumption. And the radios use approximately radios in the cellular network today use about 2% of all US electricity. So you're talking about using 100% of all US electricity to do that if you go down the legacy path. And you do the math, it also turns out you're talking about $1.2 trillion of equipment. Place I went to school for undergraduate, one of the locals would be saying, that dog don't hunt. And it's just not going to happen unless a fundamental change happens. And that's one of the things we realize we're about at Eridan. What we represent is a way to reduce the power consumption of those 5G radios by about tenfold in an environment like I'm in here in Silicon Valley, and as much as 100-fold if you're out in the middle of Kansas or Nebraska, and reduce the CapEx by an almost equal amount. And so now CapEx being the amount of money that's necessary to roll that system out. So I think it's important to recognize, I said I was a physicist, right? Nature abhors a vacuum. And what's happening is the technology has gotten to a point where there's this massive opportunity that the technology can't serve because it's in this box of how much power it uses and how expensive it is. What that does, we're not the only ones. There are people like Starlink who are trying to figure out how do we do this with satellites. There's us who are figuring out how do we do this with a completely different circuit architecture in the radio. There's other folks who are trying to figure out how do we close this gap. That gap, I anticipate, will start to close very rapidly within the next 3 to 10 years.
Yeah, for sure. I mean, it sounds like from what you're saying, especially on the energy consumption piece, that the current deployment model for 5G is potentially not just detrimental, but also impossible for global scale, global coverage. So, what is it that needs to be done? I know you kind of talked a little bit here and there about it, but what really needs to be done in order for 5G to meet those expectations that those coverage maps kind of aspirationally are sharing? For it to be something that can be utilized in rural areas, other places, not just major metropolitan cities.
Let me put an exclamation point to your statement and then answer your question. So there was a newspaper article about 2 months ago where the CEO of AT&T acknowledged that they were surprised by the electricity bill for their 5G systems. And that in response, in order to manage their electricity consumption, they were outright turning off their 5G systems at night because they're pulling so much power in an attempt to save $1 billion in their electricity bill. All right. Just to give you a sense, and that's just one major network operator. All right. It's a huge challenge. So how do we change that? Two things. First of all, we as a technology actually are optimal at lower powers and smaller scale. One of the challenges with the existing approach, the existing technical approach to how we build 5G systems is they only reach the marginal efficiency that we're seeing today for the biggest systems. That means that it only makes cost-effective sense to put those systems where you have enough customers to support those being used, right? So the first thing you want to do is to be able to push the scale at which those systems become economical to deploy down to the granularity and the level that you're going to see out in ag tech or forest or mining tech. That's one of the things that we do as one of the MNOs that we work very closely with, mobile network operators that we work very closely with, said when they saw what we were doing and they saw it at demonstrations, you actually make small cells small. And it's that kind of thing where now you can put it in a small ag tech community down in the Salinas Valley here south of San Francisco, and where they have next to no coverage today. And for a cost which is something on the order of tenfold less than a mobile network operator could put in coverage, you can come in and give them municipal coverage. Is it going to give them the ability to play, what's the massive multiplayer war game online?
Call of Duty? Yeah, right.
No, not going to do that. But would it give them sufficient coverage to be able to have emergency telephone communication? Would it give them sufficient coverage that the kids could download their lessons online and be able to have school and you could even watch Netflix because it buffers, right? Your lag will be meaningful. Your lag will probably be half-second like lag, which you would never want to try to play a game with. But this isn't about playing games. This is about actually providing very meaningful capability. And IoT actually is one of the most forgiving applications with respect to some of those characteristics. And therefore, the financial driver of the IoT work is going to be one of the things that's going to pull that network diversification out into the underserved communities.
Absolutely. Yeah, it's super interesting to kind of hear your insights because like we've covered 5G before, but not to this extent. Like not really talking really down into the nuts and bolts of what's driving coverage. Because for us, we've always talked about just with different types of connectivity available for IoT solutions, it's making more solutions, more use cases, more making them more plausible now than they ever have before. And 5G comes up all the time, but there's a large section of the country and the world that obviously will not be able to see those benefits. And kind of what you're talking about really explains as to potentially why, but also what can be done to change that. And that also goes into the conversation around sustainability, which is something that we just started to kind of dive into a bit further with guests is the kind of the connectivity sustainability across all different types of connectivity when it comes to IoT. But how do you kind of think about the how to improve global connectivity sustainability and kind of the why it's so important for us to be thinking about lessening the impact that 5G has on the environment? Like what will be done to ensure that is something that is not as big of an impact as it probably is now?
I could talk about this for hours. Like I was talking about this morning. So some of my colleagues in the IEEE, one of the International Organization for Electrical Engineers, we're a part of a small working group on the next generation of sustainable 5G communications and beyond. And how do we even come up with figures of merit, and how do we figure out, hey, we want to drive the entire process towards sustainability? And so you start thinking about um, not just the power consumption that the network is exercising, but how much energy did it take to actually put the network in place in the first place? How much energy did it take to make that networking equipment? How much energy did it take if I'm going to have to run a power line to that location at $1 million a mile? That $1 million a mile is reflective of the cost. And amazingly, you can actually correlate, unless you're using gold and platinum everywhere, cost has a very, very high correlation to imbued energy. Because the number one cost that we have is the energy to make something, the energy to move something, the energy to carry something from A to B. And, and so part of what you then get to is, all right, what I really want to get to is a base station that I can put in small town Kansas, 500 people spread over a 5 or 10 kilometer diameter footprint. And I want to be able to go on top of that, the town hall. I want to be able to put up 2 kilowatts of solar panels. I don't want to have to run power to it. And I'm going to put some batteries there. And that's enough that I have my connection. I'm done. I'm not running a high voltage power line. I'm not running XYZ. Now, if you think about the remote stuff, now all of a sudden I have a 2,000 acre farm in Missouri, and the farmer now can go and put that in place and cover his entire farm with one small installation. Oh, by the way, he doesn't have to pay. It turns out that if you do that in the middle of the farm, the number one cost you end up with is the cost of getting the power into the middle of the farm. And now all of a sudden what you've done, you said, okay, $100,000, you can put up your own tower. You're done. As opposed to it's $100,000 for the tower. Oh, by the way, it's $2 million to get the power to the tower. So you start to unblock these things. We had a very interesting call with a group from Indonesia who's looking at how do we get 5G to our villages that are up in the mountains and in the jungle in Indonesia, because it's inconceivable that we would actually be able to try to drive power up into those locations. And their application, and this is crazy pants. When I heard about it, I was kind of like, well, duh, I didn't realize anybody. Their application is banking. They just want people to be able to have a transaction and buy an order online. It's simple, little, tiny things that you and I take absolutely for granted. I can pick up my phone and make an order on Amazon in the next 3 minutes. And you start to think about, okay, we get this to where we now connect the world. The world now has access. I mean, that's our connecting the planet is what we talk about with the little subtext of without burning it up, right? I mean, that's really what you're talking about. And that's what we look at. That's how
Sure.
we think about it.
Yeah, no, that's fantastic. I think it's important to think. You were talking about the example of in Indonesia being able to get connectivity so they can do the basic things. When we think about connectivity in the IoT space, I don't necessarily think we talk a lot about why connectivity is so important outside of what it does for the solution. As far as like obviously each solution requires a certain level of connectivity for different things depending on bandwidth requirements, latency, all these different kinds of things. And but we don't talk too much about the other side of it, which is the lack of affordable, lack of ubiquitous wireless connectivity and how it adds cost and complexity to IoT deployments. And how do you see 5G kind of like, I guess, fitting in there? Does it help solve that? Or just how do you think about that challenge that the IoT world kind of sometimes faces and why it's so important for us to focus on these things?
So one of the things that's embedded in 5G, I think a lot of people miss, um, and I'm old enough that I experienced this, and as I thought about it, I was like, okay, most people aren't going to understand this, but it's really important. I remember making the transition from MS DOS to Windows, and I remember being really thrilled with Windows 95. And then we made the transition to, I want to say it was Windows 3 or something along those lines. And you went from a single thread processing operating system to a multi thread processing operating system. That is the change that is absolutely the most important thing about 5G. Or radio will allow that, or radio technology will allow that to be pervasive around the world. But what that really specializes in is that that network can actually do multiple things simultaneously. It used to be the case that if I was sitting writing a Word document and I wanted to shift over to doing an Excel spreadsheet, I had to close the Word document and open the Excel spreadsheet. Now you can have 16 windows open at a time, right? And as things are updating, they'll come in. It's not like my mail program on this Chrome tab isn't updating as you and I are talking. It's updating, and I'll go over there and it won't all of a sudden upload a bunch of emails. They'll be sitting there ready to go. That is incredibly important. And as I think about how IoT merges into the overall 5G stream, what that starts to suggest as you think about it is, okay, it's capacity as catch can. That's the way I think about, a very, very simple way, how I think of IoT being merged into a 5G stream. It doesn't have its own, I own this part of the spectrum. It's, I'm seeing spectrum not being used. I have an opportunity. I'm going to be completely silly. I'm going to think of an IoT Kindle, and I want to have, and for a school book or something like that. And I want to download the stuff when I'm not taxing anything else. And it sits there and it pulses out and says, I want to be able to download this book. And when there's some capacity, the network has the autonomy and has the capability to say, I've got the capacity to send you your book. And it just does that. As we start thinking about what this means, we're just scratching the surface today as to how we think about IoT. What's going to happen over the course of the next 5, 10 years? We're going to look back on this period and go, how didn't we see that coming? So as soon as we see these capabilities coming out, we will have our beta system ready for some early deployments this fall. We'll probably be putting out our first commercial systems end of this year, beginning next year in low numbers. So within 2 or 3 years, you're going to start to see some really interesting test cases of people taking advantage of that and putting out, oh, I have a new IoT thing that automatically turns on the water for my vineyard. I'm going to have a new IoT thing that automatically senses. This is one that I heard from a colleague from Stanford, and I was just like, that's really brilliant. They have an IoT camera on a drone flies over a recently planted field and can actually measure how many of the seeds that got planted in a row are coming up and communicate to a drone behind it to go through and put in extra seeds where the seeds didn't germinate. And so instead of having to overplant and then pull out the shoots that are too many, now it's just in time delivery of seeds. Are you freaking kidding me? And think about how that you're doing this over thousands of acres. Return on investment is like one trip.
Yeah, it's unreal to think about these different kinds of use cases for sure.
It's going to be pervasive. And we're going to look back on this 10 years from now and go, how the hell didn't we see this coming? Except for people like you and your listeners, we're going to go, yeah.
Well, Doug, you have some fantastic insights that you share with our audience today, and I truly appreciate your time. For our audience who wants to learn more about either of these topics, connect with you, connect with the company, learn more about what you all have going on, what's the best way they can reach out and engage?
Eridan.io is the web address. We're on LinkedIn a lot of times with posts about the kinds of things we're doing and where we're going. We love to hear from people. We are constantly amazed at some of the ideas we hear people come in with, and we're like, how did we not think about that? So it's really amazing. Thank you for having me, Ryan.